Good day, viewers. You are welcome. Here we want to find this. We want to solve these exponential equations for the value of a that satisfy this. So here is the method we are going to use to solve this. So suppose we are given 1 to the power of 4 to the power of a equals a. So to solve this, we have to separate this first, as we have this as 1 to the power of a divided by 4 to the power of a equals a. And note that anytime we have 1 to the power of a, irrespective of the power of the value of a, everything gives us 1, either positive, negative, or 0. So we get 1. So therefore 1 to the power of a results to 1 divided by, so here is 4 to the power of a, everything equals a. So then let's try to cross multiply. We multiply 4 to the power a with a, and we have a multiplied by 4 to the power of a equals 1. So if this is what we have, then from what we have here, I want to apply a rule called Lambert W functions. But the rule says, suppose we have the Lambert function of x exponential of x, this gives us x. That is, this coefficient and the power of this exponential must be the same before we can choose x, which is the coefficient or the power of this exponent. That is a constant. So we apply this where logarithm has a limitation, where we cannot use logarithm again, so we apply this. Alright, so here we have a multiplied by 4 to the power of a equals 1. So what I'm going to do here is, suppose I rewrite this as, if this 4 is written as e raised to the power of ln 4 to the power of a equals 1, as e and ln, they are inverse to each other, they later cancelled, so I just try to introduce it to get the result I want. Now according to the rule of logarithm, so the power of this 4 will come here, as we have this as a multiplied by a to the power of a ln 4 equals 1. And we have to follow the formula above, that this coefficient and the power of this exponent must be the same. And what this one is missing is just ln 4. That is, we try to multiply ln 4 to both sides, so that we have ln of 4 multiplied by this a, then multiplied by e raised to the power of a ln 4. Everything equals to ln 4, as I've already multiplied both sides by ln 4. Then we now introduce that function, which is Lambert omega of a ln 4 multiplied by e raised to the power of a ln 4. Everything equals the omega of ln 4. Alright, so now we have the rule that has already uniformity this. It has make this one uniform. That is, you can now apply the rule and take a ln 4. So by taking a ln 4, we have a ln 4 equals the omega of ln of 4. But here we need to know the value of a. We have to divide both sides by ln 4. So by dividing both sides by ln 4 here, we have this cancelled, so that a equals the omega of. But let's try to do something here. Suppose I write this as 2 ln of 2. So 2 ln 2 is still the same thing as ln 4. Then everything divided by, let me just write this as 2 ln of 2 as well. But we cannot cancel this and this, because this one is in a function. This one is not in a function. So what we do here is, suppose we write this as a equals to omega of. So for this 2, I'm going to rewrite this as e raised to the power of ln 2, then multiply by ln 2. So everything divided by 2 ln 2. As what we have here, so we can consider it as what I already written above as the function called Lambert omega functions. So therefore, By choosing only ln, since the coefficient and the power of this exponent are the same, we have to choose ln2. So by choosing ln2, we have ln of 2 divided by 2 ln2. So here is 1. Then ln2 cancelled ln2, and we have the value of a, which is 1 divided by 2. As 1 divided by 2 is the value of a, it satisfies this problem. So by check, so let's try to check if it's satisfied. We have 1 divided by 4 raised to the power of a equals a. Then by replacing a with 1 over 2, and we try to transform this 4 into 2 raised to the power of minus 2. Everything raised to the power of 1 over 2. So we know that the a here already is 1 divided by 2. So when this cancel this, so we have 2 raised to the power of minus 1. And 2 raised to the power minus 1 equals 1 over 2. It means that the left hand side and the right hand side of this equation are equal. And this is how to solve this problem with this method. So I hope you learned something today. And if you have another method of doing this, you can drop it in the comment box. And don't forget to subscribe to this channel and turn on the notification bell. See you in the next video. Never stop learning. Bye bye.